Alright, cool. Looks like we are live. Nice, nice. Yeah, I guess we're live. So, what's up, y'all? How to size bets, thousands of Mazdas. Alright, let's see what's on Hacker News. How Telegram became the anti-Facebook. Nah. I think Facebook has had a lot of shit piled onto it in the past few days. I'm not going to talk too much about it. It's definitely interesting what happened after the earnings, though. I think people are like finally reevaluating the markets and really taking a realistic look at what they can get, from 5-10 years out from now. Let's see what else we got. Geometric Storm. The unlimited storage that Google promised my university is being discontinued. All right, let's take a look at this one. Looks like the unlimited storage that Google promised my university a couple years ago is being discontinued. I can fill an entire institution being limited to 100 terabytes. I can fill that 5 times over with our data. This is precisely why I want to maintain our own servers as a prosper investment of taxpayer dollars. All right, sure. How to migrate 5 petabytes? God forbid it's okay. So it looks like this guy had his university sign up for some kind of Google, or maybe not university but lab, sign up for using Google for free, and then now it's being discontinued. The 100 terabyte storage. Another example of how thinking 2 steps down the road has saved our bacon. All right. Wait, what? Had I gone down that road, I would have effectively had a couple of months to figure out how to migrate 5.5 petabytes of data to a new solution on top of the giant the grad decline deadline I need to make. So I'm guessing that he actually put in his own servers and stuff. All right. Was thinking 2 steps ahead down the road and war game any big decision you have to make. It pays off and again and limits the advantages, and again both in terms of advantages and limiting damages. Yeah. We are a small lab in the space that we compete in with much larger and much better funded groups. We have had to be careful and work harder than perhaps we might have had to do, but stuff like this could have crushed our research efforts. Interesting. My question is, why was this actually done? First of all, let's take a look at who this guy is. Neuroscientist, photographer, and advocate for special knowledge. Director for Mark Labs Lab in Utah. All right. So I'm guessing Google actually promised them some unlimited storage plan, and then they just kind of capped it. But then he decided, you know what, we're not gonna go with Google because it's relying on some third party. I think that's pretty reasonable, especially when you start dealing with like big tech, and you have to start looking at who you can rely on. I think that's a very good question and a very good response from this guy. Although I'm really more concerned about like why like this even happened to begin with. I mean, it makes sense. Like, Google promised you free because ultimately they want you to get on and sign on to use their other products. But then, if you're like a small time, what's it called? Lab, then you really don't have the money or the bandwidth to deal with that bullshit of switching over. So yeah, I guess for whoever's watching, we're gonna be looking at a few news stories on Hacker News before I talk to my client. He'll be here at 8 p.m. And we have 8 minutes to hang out. So if any of you have any questions about like coding, engineering, coding interviews, anything like that, feel free to ask away. Why is Google pulling a bait and switch with so many products at once? I would probably guess that it's just easy revenue. Now that they have the people locked in, now they can jack up the prices. I think that's pretty much what it is here. I think it's actually quite interesting. I'd rather pay Apple than Google, which means you'll still end up indirectly paying Google. Let's see. Apple reportedly storing 8 million terabytes of iCloud data on Google's servers. Interesting. The report now claims Apple has now over 8 million terabytes stored on Google servers. As of mid-May, Apple was on track to spend around 300 million on Google Cloud storage services this year. Really? Google Cloud staffers have apparently given Apple an internal code name that hints at its size of its customer, Bigfoot. Where are they getting this data from? Where are they pulling this from? I'm very curious. Although it's kind of that's kind of interesting. I suppose that on some level, I think every single company, whether even Netflix, you're gonna be paying either Amazon or Google, one way or the other. And I think this is kind of nature of the beast. You might at some point your own services end up being so big that you really can't handle the capacity or focus on trying to manage your own data storage capacity. I think it gets very interesting at a certain level, and I think that for a lot of smaller companies and research labs, you end up in this very, very interesting and weird conundrum. On one hand, do you trust big tech to help you in the long run, or do you just swing it on your own? And I think that the landscape of tech has gotten to a point where everyone is specialized, and everyone has a big enough tech area and a big enough problem space where they can actually just simply focus on the problem at hand. But the question is, who do you trust? So let me actually give you a very, very solid example here. Let's go to perf.dev. I think this is a very good example of this. So this actually was started by a bunch of ex-Uber engineers who saw the problem of trying to generate automatic reports for mobile devices. So for instance, if I have a mobile app and then I need to test that mobile app against a bunch of Android devices. Well, there's like thousands of different models and permutations. Now, do I set up my own rig to test against every single device in the world? Well, I could invest in buying, thousands of devices, setting up some kind of framework, and then just spend all my time maintaining that framework. Or I could contract that out to something like mobile.dev or some manual device lab in India. But the thing is that maintaining this infrastructure is expensive, and chances are a lot of other developers will have this exact same problem. So the question is, do I trust mobile.dev enough to honor the contract long enough to support my infrastructure, or do I develop my own? And I think this is actually a very interesting space because, who do you trust in this space? Tech comes and goes. There's a lot of people who are spinning up the exact same thing, and the question is, it's not just who do you trust to do the job, it's who do you trust to last long enough so that way you don't have to deal with this bullshit on your own when people, if let's say mobile.dev says, oh, we're out of money, we can't support you anymore, bye-bye, we can't honor your contracts. That's a very, very real situation. And apparently that's not unlike what this Brian William Jones is talking about. And I think that one of the solutions to this, actually, you can find this in the library tech space. And let me give you an example. So let's say that you have a library, right? Like an actual library, like your city library, and you need to manage the database for all your books. Well, the thing is that you're probably contracting the management of that database to some private company. But a lot of these companies actually have a clause in their contract saying, hey, if we go under, we will give you the source code and set you up. So that way you're taken care of. And I think that just simply having that clause in a lot of your contracts in this space, in this tech space, when you're trying to deal with a lot of B2B businesses is super powerful. I think just having that care in mind of saying, hey, we will give you the source code and set you up if we go under, I think that gives a lot of companies peace of mind. So I think that's I think it's a great way to solve this issue of trust. I think just having a legal clause, it already solves a lot of these issues themselves. And so thinking ahead is not just like, oh yeah, what solution do we go with? It's also being able to extrapolate and exploit whatever solution that is presented to you. Why does Apple want to store on Google Cloud anyway? And like I said, it's because if Apple does store their devices and their data on Google Cloud, and I'm saying if, I can't speak to it, even though having worked at Apple, I don't even know this information. But the point is that Apple probably focuses so much on their own services that they can't really, they don't want to support their own infrastructure for this. But what good does it do them? Maybe it's just more profitable to have some other entity handle all this for you. That's kind of like what it boils down to. It's about the efficiency of your capital. Do I want to spend the money to maintain my own servers and my own server farm, or contract that out to someone else? And I think that with all the infrastructure that already exists for big data, that can only really be handled by a few players like Google, Amazon, and maybe maybe Dropbox or some shit like that. And so that's why you would do it. It's just simply much more efficient use of your capital and time. Apple is all about privacy. Yes, absolutely. So the question is whether or not Apple trusts Google and Amazon, these parties that they're contracted to, if this is the case, to treat that data with the same level of privacy and care that they would. You know? And that's a question that I can't really answer. I think it's up to the consideration of whatever executive decide to sign off on it. They don't even share infos about the projects across teams. Then they store things on Google Cloud. Yeah, that's a very good point. It's like, well, internal teams and developers at Apple can't see what's going on across teams. Yet you're willing to trust a third party company. Yeah, that's a very, very good point, and I can't speak to that. I think there is some contradiction to that. It's like you don't trust your own employees, but you'll trust some random fucking company that is potentially your competitor. That's pretty hard. That's a pretty hard thing to say and to point out. That's at least the way I describe it. Anyway, it's 7:59. Let's give it a shot. Let's see what he says. Oh yeah, and I noticed that there is a question from Tic Tac in my Discord about Enron. I would say if you want to, if you really are interested in the Enron scandal, read the best and the what's it called? The smartest guys in the room. Hold up. Yeah. This one. There's a movie, but there's also a book. I think that if once you actually read it, you will understand what made the Enron scandal so fucking, how to say, big, and the mechanics of it. It's a lot of crazy ass accounting tricks. So if you want to know if you want to look at a textbook case of corporate fraud, look at this shit. All right, let's bring my client on. Hey, hello.
Hello.
Hey, what's up?
Doing good. How about yourself?
Hey, doing good. Yeah. So how did your practice go since we last chatted on Saturday?
I would say that the beginning was hard, but as you mentioned, like as I did more questions, gets a little bit better to organize my thoughts and like following the framework you passed to me, right? But still, there are some points that I still struggling.
Okay.
Yeah. Generally, like that's basically this.
Okay. What are you still struggling with? Let me ask that first.
I would say that there are three main points. Sometimes I am having a hard time to like connect small steps with the big picture.
Okay.
Few questions, for example, two question of recursion. I tried to draw like the tree of recursion. I was not like figuring out the proper way to, like create my answer. So I was like running into a loop. But for example, in the towers of Hanoi problem, that one was, I guess, the one that I most struggled because I was able to solve like the puzzle pretty easily, like in the first 5 minutes. But then when I was like creating the steps, like the result was kind of disconnected, and I was not figuring out a better way to put this into a big picture, as you mentioned, like as if it was a pint, not a novel, right? Yeah, and but let me see if there's one more point.
Okay, yeah, you said three things.
And go ahead.
You said three things.
No, yeah, there's one last thing. Sometimes I can have the answer, pretty simple, but it's too much complicated, and that thing I'm working on as well. But yeah, that's basically it. Points I'm struggling.
Okay, I understand. Okay, so let's address the first two. The first one is hard time connecting the small step with the big picture. If you have another problem other than Towers of Hanoi, which I kind of hate that problem personally, but if you have another problem that you want to show me, like in your practice diary, that illustrates this, then we can talk about it. The second one, where you say you can come up with the answer, but it's hard to implement or it's too complex, I would say the answer to that is just write it out. Once you write it out, it becomes so much more simpler and a lot easier to handle step by step. I think that you're still trying to do a lot of things in your head.
Okay.
Yeah.
Okay.
You have like an answer or a problem that you want
there's
to
a
look
problem.
Mhm.
There's a problem. Do you have access to my practice?
Like, yeah, I downloaded them already. I've seen 2 of them already. So
Yeah, hold up. If you go in the question called generate all subsets, this one, I was able to like create an idea, but was like, very complicated. No, was not that one. Sorry, was the generate strings of matched parents.
okay.
It's like 15.7, the number of the question. So
Alright.
that one I really like tried. Yeah, then I tried like the recursion stack, but was the wrong way because I saw the solution. Like I don't know how they come with those insights. It was like much more simpler than that.
Okay.
Yeah, that's it.
So what the problem was 15 point what?
15 point. Hold up.
Just give me the title.
15.7. 15.7.
Okay, 15.7, and the title is
Generate strings.
Okay.
Strings of a matched parents.
generate
Like this.
strings of matched parentheses. I don't think that's like one of the problems that you submitted to me for replay.
No. Yeah, that was not from the replay because I didn't record this one. But
Okay.
it's on the practice sheet if you go there.
Okay, can you send me the practice sheet again?
Uh,
Alright, did I send it? Oh, I think I sent it to you in the chat, right?
just a
Yeah,
moment.
yeah,
I add you
Great, practice
as a-
diary, right? Perfect. Okay,
practice sheet and yeah.
M practice sheet or practice diary? Because I'm in the Google
Nice.
Sheets right now.
Another. I'm gonna send you the link.
Okay,
Just a
okay.
minute. Go on. See if you can have access.
Is that it? Okay, got it. Let's see. Okay, practice sheet M. Got it. All right, so let's see what you did here. Towers of Hanoi problem. And then you want the string one or the parenthesis.
Yeah, the parentheses.
Is it? Okay, 15% generate strings of match parents. All right, cool. All right.
Yeah.
Okay, let me pull up the original problem then. Give me a sec. Okay, cool. Here we go. So the string in which parentheses are matched are defined by the following 3 rules. Empty string is which parentheses are matched. The addition of leading left parentheses and trailing right parentheses of a string in which matched parentheses results in a string in which matched parentheses are matched. Sure. So every open brace needs to have a corresponding closed brace, essentially. That's basically what it's saying here, I think.
Yes.
So
yes.
write a program that takes in an input as a number and return all the strings with that number of matched parentheses of parents. Okay, so you're going to be given a integer, and you're saying, what are all the possible ways that you can generate the parentheses matches? Right, okay, cool. So I see here you tried like generating all the possible sets. Okay, that's fine.
Yes.
All right, and so n for 2, n in 2. So yeah, so you saw like this trying to figure out the pattern when n in 4, right? Okay.
Yeah.
That's fine.
Then I try like to make a combination of answers. Like, okay, if I go to 3, what can I like reuse? You know, from 3 to the 2 make the work.
Got it.
I was not like connecting the idea.
I see. So let me look at what you did, and I'll tell you how I would have approached the problem. So base case n equals 2. Yep. So you took them base case, generate all possibilities. Okay, I would be a little bit more specific about this. Like, how is this possibility generated? That's the first thing. Like, I want to be a little bit more detailed about this because to me it's not obvious, right? I mean, maybe it is to you. To me, as like this is a little vague. Because if I ask a 5-year-old child to generate all the possibilities, it's like, oh, you'd probably just point to what's called this set, right?
Yeah.
Yeah, here. Wait, actually, let me share my screen with you. It may be easier.
I was like following on the live, but anyways.
Oh,
I
okay,
think
yeah,
it's
yeah. Okay,
better.
I don't need to then. So you might say, oh
Yeah,
yeah,
I
I'm
don't
just
need
gonna
to.
generate this set. Generate
Mhm.
this.
Right.
Okay, that's fine. Concat each possibility with the upper level parens. Returns possibility
Yeah.
generate. Concat. Uh, yeah, I'm gonna say right now this is a little bit messy. Let's see, generate all I'm really trying to read this. Let me see what happened here. Generate all the possibilities for all indices from local index to n. Okay. Shift current element. So the question is, how do you generate all those possibilities?
Yeah. Oh, the thing was, I guess that was the problem. I was trying like to generate in the wrong way,
Uh-huh.
because my line of thought was like, for example, I'll try. Yeah, that was the point I even addressed on my diary.
Mm-hmm.
For example, I tried to create all the open and like closed parentheses. For example, 3 open, 3 closed, right?
Uh-huh.
And then I was like trying this messy idea of like, okay, if I shift the parentheses instead of close, like instead of open, close. So and I'll check if that's a valid.
Okay.
And but that was totally wrong.
Mm-hmm.
That was like the solution was like to yeah, always count the number of parentheses and yeah, make a possibility like this.
Mm-hmm.
But I think yeah, I went in the wrong direction.
Mm-hmm.
If I went yeah, basically that.
Okay, I'm gonna tell you how I think you weren't completely certain of like how the generate possibilities. So to me, like this just completely very vague. So let me show you how I would have done it, and maybe this will make maybe a light bulb will go in your head, right? So when I
Alright,
see
great.
generate something, I'm just like thinking, okay, there has to be a way to reuse the states, right?
Mhm.
So immediately, I'm going to just start from n equals 2, n equals 3, right? So now that you have this beautiful pattern set up, let me actually highlight in red. So now I see this. I'm going to say, okay, what is the link between this n equals 2 and n equals 3, right? So I'm going to look at, let me copy this first and then highlight in red, right? So I'm just saying, okay, well, in what ways do each of these composite in order to make this, right? So let's start with something very easy. This to me screams, hey, wait a minute. This is just a parenthesis. Let me just do this in purple. This is just a parenthesis plus one of the n equals 2 combinations, right? Because this is just, I'll put a parenthesis on the left-hand side. Or the right-hand side, right. And then this is just the exact same thing. So I know that at the very least, this represents a left-hand side of the parenthesis plus all the permutations at n equals 2. And that way I can generate this. That's the first thing in my head. And then I see this, right? So then I'm thinking, okay, well, this is on the right-hand side. This is on right. So let me change color again. So this is first right-hand side plus all permutations at n equals 2. And so, okay, well, if this is the case, then I need to be able to say, oh, well, this got repeated, right? So, like, okay, this is kind of overlapping. So, overlaps with the last element, right? I mean, and then I'll say, like, okay, well, for now, I'll just throw it all into a hash map or a hash set, because then that'll just get canceled out. Because the string will be red. That's fine. So then this last element here. So then what am I doing here? Well, then here, I'm going to say, hey, well, how do I get this? It's like, okay, well, I'm going to put left element, right element, and then all permutations at n equals 2. That's basically what it's saying to me, right? Because if I look in here, I'm going to say here, here, and then I have this highlighted here, and then now I have this crap in the middle.
Okay.
Boom, which is like, which I see in here, right? And then this one is just the exact same thing. It's like, you know, like it's you get the idea, right?
I got the idea. Yeah, it's repeating. It's repeating, but yeah, for the other side.
Right. And so once I've identified this, I'm like, okay, great. I have a pattern I can work with. Now I'm going to tell.
I was able to do it.
Huh?
That part, I was able to do this part.
You're able to get this, right?
I was able to get this point. Yeah.
Okay. So what I would have needed you to do is for you to write this shit out. Because once you write this out, then it's like, oh, well, now you know what to do. Because now it's a very clear rule set. I still think that's the right way to do it. If you were to get there. But to me, when I see all this, what you're doing, I don't see a very clear rule. You know, I would have liked for you to make this very explicit.
Okay. I was trying to go like with the walkthrough. The solution is in red if you go
Yeah,
down.
I see.
Oh, yeah, yeah. There's like a solution I found, which is like good. If you go, they go in a different approach.
Okay.
You see that one? Yeah. So this is yeah.
Okay. So I think that you were that's would have been the right way to do it. But either way, let's take a look at what they did. Generate parentheses, backtrack. So if open n equals closed n equals 10. Ah, I see. So they decided to count the open number of ends and the closed number of ends. I got it.
Yeah, that was the tricky. Yeah, I never thought about this.
I mean, I think that this is just an optimization on top of this because now that it makes sense. Yeah, I think this makes this makes sense. Let me see if I can try to figure out how to what's the best way to jump from where we did to get to here. I still think your solution is correct, isn't it not? Or oh wait, no, I realized. You might have to start putting in some weird combinations. This probably would have came out of testing the n equals 4 situation.
I ended up in having the same conclusion as you had, but I think to myself, well, I had to do the shifts that way I put, but I need to like do all the permutations as well. So there's like 2 steps. And I think to myself, well, this is gonna be way complicated, and I need to like define things here. And I wasn't able to like do this pretty detailed. Well, I think this was a brute force solution, and this is more optimized one. But yeah, I was like stuck on this brute force part.
Oh, you were stuck on the brute force.
Yeah.
Okay. Then I would say that if you got to this point and then it's like what I really want to do is focus on your approach to it, because once you have a clean approach, the answer will fall out and become very obvious. So I would have liked for you to, at least to define the rule set very clearly. So this is what I mean by kind of like writing it out. You sound like how I wrote it out.
Yeah.
I want you to do that.
All right.
And so the next thing after that, it's like, okay, I get that at some point, if you try doing n equals 4, I think that you would, let's hand wave and let's say you arrive at something complicated, right? So then at some point I would have said, oh shit, I do left hand side, and then middle for, n equals 3 and then right hand side. Let's say that was complicated as shit, right? Because especially keeping track of the middle permutations, right? Then at some point you would have had to realize, what am I doing that is so complicated? Well, I'm specifying exactly where all these different parentheses need to be. What if I didn't have to be that explicit? I think that's the key here, is that it's just like one angle to optimize against is the complexity. That's probably would be the trick here. So then it's how do I make it more simple instead of like having all these predefined permutations.
Okay.
So that's basically the way I would have seen the problem, and then get to the generate parentheses. But I would say that would have only occurred if I actually walked the problem. So I'm not going to blame you, but I will say I'm going to blame you only on the approach. No, I'm not going to blame you for not getting an answer, but I'm going to blame you for not doing a clean approach. And I think that's what's going to help you actually visualize what you're doing. Because you mentioned before that you were running into some complexity.
Yeah.
So being explicit about these steps is going to help you a lot.
Okay, if you see, I basically did like 2 cases. For example, generate all possibilities, right? And if you go like down, a little bit down.
Yeah.
There's like a second step for it that is like generate all the permutations of like the possibilities, because I figure out this with the n equals to 4. If you go there, I organize like the lines. Okay, if I do all the permutations and then make the same for the inverted order, it's gonna work. I will have all the possibilities. Yeah. You see, for n equals to 4, I figured out that. You see?
Yeah. So you figured out the order, and that's fine. Like your answer works. Of course they're gonna be more clever, and the question is like, how do we get there? But again, I want you to be much more explicit about the rules. Because you know, like you can just say, oh, I drew it out, and yeah, that's fine. But now I want you to be explicit about it. Now that you've seen it, define it into a proper rule set. Because now that like you see this is easy to convert into code.
Yeah.
So it's being able that's probably what's the missing piece here. Is like you did the first step, right? Now what is the follow up after that?
Okay.
So
Try to define the rule sets. Yeah.
yes, be explicit,
Okay.
and be as detailed as possible without being overly pedantic. It's like understanding what the important thing at the moment is, and at this point, the important thing is being able to find the rules.
Okay.
Does that make sense?
Okay. Totally.
Okay. I also looked at your replays as well. I saw 2 of them.
All right.
And I kind of want to
Alright.
go over like a few things I saw. So
Okay.
let me open up, make sure I have the right one open. I only open. Okay. So reconstruct binary search tree from traversal data. Is there any? Tell me what you thought when you did this problem. Like your impressions. How, did you do well? Did you not do well? Etc. Etc. Or like any like mistakes you felt like you could have corrected.
This one was the last I recorded. Actually, in my perspective, I think I figure out the thing of like divide the portions, right? Of like the left portion and the right portion, like to put into the child's and the next child's. I think was good. This was good.
Okay.
And let me see. I have notes of this. Yeah, I test all my hypotheses and walk through this, and after this, after all I designed, I tested, and I think was good. I think was a good question because I think was pretty easy for me.
Did you compare your answer to what the book had?
Not yet. That was actually the last question I did, and I was like only reviewing the points here, just to. Yeah.
Do you know what I'm about to say?
I think I know just by
What do you think I'm about to say?
I should to compare and see the inefficiencies if was compared to the book actually.
Yes, you should compare it to a book because let me share my screen for a second.
Okay.
Okay, can you see this?
Hold up, it's loading here.
Okay.
Still loading. I think that's taking too long to load your screen here.
Okay, it's taking a while. I might be okay. You got it. If I'll try switching to 720 if you need me to.
It's trying to load in 1080.
All right, let me switch it. Let me stop. Let me change the stream quality to 30 FPS, and then to 720. That should be better.
Okay.
I mean, I have Nitro, so I get to have all the nice stuff.
Internet in Brazil is not that good, so the
It's all
lowest
good.
you can put. Yeah.
It's okay. Yeah. So let me know when you can see it.
No, not yet.
Okay.
I think I can follow in the live. It's pretty okay.
Okay, fine. That's fine. That's fine. So what I'm going to say is that you see this current node dot left that you got going on at the end. Hello? Oh, wait. Your mic's muted, by the way. Hello?
Oh, hello. Yeah, here I'm back.
Okay, cool. So you see this current node dot left you got going?
Yeah, as I see.
Is that a bug, maybe?
Oh, there's like two current lefts.
Yep.
Yeah, it should be one right and one left. Yeah.
Uh-huh. So this is why it's important to look at the book. And
Yeah.
there's a second thing I want to point out here. What else do you think is wrong? Well, I wouldn't say wrong. Else do you think is inefficient with this?
Just a minute. Let me analyze here.
Mm-hmm.
Actually, Yeah, I see the error. Yeah.
What's the error?
How can I, like the list? I am like updating the list, but the list in Python, if I pass to the another call stack, it's gonna be different. So I need to pass copies of it.
You
So
are
that was
passing copies with it. I'm pretty sure that's how Python works when you split an array like this. It's a deep copy. So, what does that do to your memory?
oh, it's gonna mess it up.
Uh,
Oh, the question. Yeah.
Yeah.
I should have paid attention to that. Yeah, for sure.
You see why it's important to look back at the problem and compare your
Yeah.
answers?
Yeah, I would do it. I do this. Yeah, basically for all the questions, but yeah. Anyways.
Anyway, I'm
That was the
noticing a pattern actually. Now that we're talking about this, I see that you're rushing it at the end. I had this problem. I'm gonna tell you. I seriously had this problem, and it bit me so many times in the ass. I was like, and you would not believe how many like opportunities it cost me. So I'm gonna harp on you on this because I know the pain of like getting 99% there and then just being so impatient that that last 1% fucks me up. So I'm gonna be mad. I'm gonna come on down hard on you. Compare your answer and make sure you test your goddamn code after you're done.
Okay. Okay.
Because this shit, once you actually understand what's going on, it's like, oh shit, I should have considered the XYZ. It's that last 1% that will give you a lot of value.
For
So
sure.
now that you understand that, and I want you to compare it to the book, or at least now that you know what the problem is, try to figure out a solution before you look at the book.
No, for sure. I'll do it.
Good.
Do it, and then I'll compare with the book. Yeah.
Mhm. Yeah,
One
let me
question.
actually-
One question about this. For example, I would test my pseudocode and then test my code, right? So, like, test three things. First, the hypothesis,
Mhm.
pseudocode, and then like the code itself, right? Okay.
Yep. So I get it's gonna feel like, oh my god, I'm spending so much time testing. Don't worry, eventually the training wheels will come off. But what I want you to do is get into the habit of like just smoke testing your idea, making sure that you have the proper safeguards set up before you take them off. You know, like
Okay.
because when you're actually coming with the idea and you're doing all this, you should already have some idea of where the pain points are going to be, what the fuck can go wrong, and how do I like prepare myself ahead of time. So being able to do this test over again will help you visualize and make sure that you didn't screw anything up. Right now, we're just kind of getting out the bad
Okay.
habits with it. Does that make sense?
Totally. Makes sense.
Good. Because you did that on another problem as well. So let's go over that.
Okay.
I think it's this one. I think it's this one. It's the generate subsets of K. So let me look at my notes. Give me a sec.
Let me remember this problem. Okay, yeah. I
Oh,
remember
size
that.
K, right?
Yeah.
So I was okay.
That one, I tested it, and I figured out one problem. The
Mhm.
pointers, the question basically was like this 99%, as you said. But the pointer I was passing, I ran into like the debugger to see
Mm-hmm.
only one piece of the subset was wrong, but that was like not the right answer.
Mm-hmm.
And yeah, I analyzed very close, and was the pointer that I was passing that was like the wrong one. I mean the pointer, the index, right?
Yeah, index, and then
yeah.
also you need to limit your subsets as well, because the range index to n, you're basically just spending more time. I'm surprised, like I'm surprised that the submission machine didn't time you out, but yeah, that's one other thing I noticed here is that when you're generating all this, the n needs to be limited to 2, because otherwise you're going to be doing so many more possibilities than you need to be. So. Now that you know what the problem is, I want you to really think about like, or look at what went wrong in your approach that you can do to prevent this mistake from happening in the future. That's where you do the learning from. It's like it's not in doing the problem; it's in studying your own mistakes.
Yeah.
So I'm gonna write that down. Study own mistakes. Okay. So then generate possibilities. Okay, let me actually look at your practice diary and let me see how you recorded this in your diary. Because you really need, because I'm going to say that you really need to do that. You really need to like look at your own mistakes and figure out how you're not going to make that again. So
Okay.
let's take a look at your diary. So let's see. Construct BTS from traverse. So test my hypothesis that code was the faster part. You made a mistake. I really want you to fill this in later. Make sure.
Okay.
Yeah, fill that in with like what mistake did you make and how you could have done better.
Okay.
Because I think you might have heard me mention this before, but just simply saying be more careful is like it's pointless. It's because how much more careful do you have to be? What are the explicit steps? It has to be actionable. It's like I made this mistake because I did not think about XYZ. Therefore, next time I do a problem, I need to think about XYZ. In like the last case, it was like, oh, I didn't think about the memory I was using. I didn't think about how the Python mechanics work. Therefore, next time I do a problem, I need to be aware that array copy or array splitting uses more memory. That's actionable. You know? So
Yeah.
the other one is like would be this, like, okay, well, I need to be able to test my code after I've written it, and then I also need to be able to make sure that I pass in the right pointers, that I'm not going over or under. And this is where like testing your code and walking through it once will help you. And being able to do like the stack trace calls and being able to say and alt and assign the variable values and all that shit.
Mm-hmm.
So really record your mistakes in your diary. So let me look at the other one. What is it? The other problem that you did was the freaking traversal reconstruction.
Generate.
Right?
What was that?
The traversal reconstruction.
Okay.
Yeah,
Yeah,
did you write that
actually-
down?
Yeah, this one was right now, but I would write now.
Okay.
Yeah, you're right. Because I thought I didn't analyze. Was a mistake of mine. Yeah.
Mhm. The biggest thing is being able to analyze your mistake and compare it to the book. Did you do that with all the other problems?
I did.
Good.
But sometimes for some questions, I just compare with other solutions as well.
No, you need to be able to compare with the book solution. I mean, other solutions is
Okay.
great and all, but I would say just stick with the book because for now, you'll get there later where you want to draw ideas from everywhere else. Right now, we're still at the basic stage, so it's not bad. It's not a bad attitude to have to try and draw from other places. But for now, we want to be consistent.
Okay.
Yeah, and I
Okay,
want you to be
we're
very
gonna consider
disciplined
only
about
the
this.
book. Okay. One question about like this analyze part. I got a little bit confused. I would say. Do you recommend like do all the, let's say, I have like 6 hours to study.
Yes.
And then take like one last hour to analyze my problems, like the problems I did, or like after every problem do this analysis.
After every
Since
problem,
it's
do this
fresh.
analysis. The reason why is because we spend as much time as we need to in order to make sure we never make the same mistake again. You know why? Because it will pay off dividends in the future. If I can, let's say I do like 100 problems, I can spend, and each problem takes me an hour, right? So
Yeah.
I can spend that one extra hour to prevent myself from making a mistake later on down the road. You know, and chances are it'll pop up like 3-4 times. So for every hour or every unit of work, every unit of time I spend right now to prevent that mistake, I get 3 to 4x that amount of time back.
Okay. You're right.
That's 3 to 1 leverage. That's freaking amazing, you know? It's like if I get like imagine if I invest in the stock market and I get you know they make like 10% per year, right? Getting 30% per year means I double my portfolio every 3 years instead of every 8.
Yeah.
So this is like what we're talking about, compounding and being able to make sure that our freaking mistakes don't happen again.
Okay.
So-
So focus on quality, not quantity.
Exactly.
Yeah.
I don't care if you have to spend double the amount of time if it means you get triple or quadruple the reward later on.
Okay, we'll keep this in mind. Just note it as well.
Yeah, just think like I guess the rule of thumb is every hour you spend right now preventing a mistake is you're saving yourself 3-4 hours later. Where you should be really mad at yourself is if you are making a mistake, you compare it to all the other mistakes that you made, and you see it happen again. That's the part you should be really mad at yourself for.
I was at some points, yeah, because I was like analyzing my past mistake and I saw how how this happened again. But boils down in the thing you said.
Mm-hmm.
I wasn't being very clear how to prevent. I was like only addressing the mistake,
Mm-hmm.
but not okay. You should do this, this, and that to
Mm-hmm.
prevent that mistake. Yeah, but we'll follow this pattern.
I would say go back over the entries that you said that where you didn't specify that, where you didn't explicitly state how you're going to prevent your mistake, and then put that in there. Because then once you have that explicit step, then you'll know, hey, well, now that I made this same mistake, did I follow what I said I was going to do? If it's yes, then that means that it wasn't enough, or you might have targeted the wrong, the wrong step or the wrong way of handling that mistake. And in which case, you need to go back over and reevaluate. But the point here, you get the point. The point is prevent that mistake from happening.
Okay.
Okay. Yeah.
Okay.
So feel free. I would say going forward, do a quick look. Go back over the problems. Look back at how you can prevent the mistakes from happening again. You seem to have done quite a bit of recursion problems, and I was really surprised you actually got through all of it so quickly. So, but now I realize that you got through it so quickly because you didn't actually do that exercise of properly thinking about how you can prevent your mistakes from happening again. So.
Yeah, I will analyze them.
Good.
Again, see if I'm covering all the things and yeah.
Mm-hmm. Is there another problem that you want me to look at, or you felt that really you couldn't figure out why you made the mistake, or something like that?
Just a minute. Let me just check here.
Yep.
Oh yeah. There's a problem called generate all non-attacking placements of n queens. So I was able to create a solution, right? Mm-hmm. But it was much more simple. Reading I guarantee I read and understand all the book was saying, because very tricky for me, because they did this in a much more simple way than what I did. I overcomplicated this in a thing that was obvious to avoid. And that one one was.
Do you have the sheet for this?
Yeah.
Cool. Can you send it to me?
Just a moment. It's in the same, but it's on the top of that.
Oh, it's in the same sheet? Okay, got it. Let me pull that up.
Yeah, it's on the fifth page. On the sixth page, yeah.
Okay, sixth page. Generate on attack placements are not queens. Alright, cool. So then output for if you're 4 queens, okay, yeah, you're gonna try this. 1, 3, 2, 0, did not work. Why does this not work?
Because if you see the ones I made, I was trying to see the possibilities. Where can I fit another queen?
Right.
And then from this one that is not working, I cannot fit 4 queens here and make all of them work. So
okay.
Yeah, because
I see.
It was basically this, and
I
was discarding.
I got. Now I understand what you're trying to say. I'm going to tell you right now that this actually does. Why can't you? Oh yeah, I see. So right now, what you did, it doesn't work. But I think you might have jumped the gun. Because think of it this way: you're trying to predict where the other 2 queens go before you've even placed them. This is what we call biting off more than you can chew. I would say it's very simple. Just place a queen on the available spot, and then try to place another queen on the available spot. And if there's no more available spots, then the solution is invalid.
Okay.
So I think that's the problem right now, is that you try to do too much on one step. Let me see what you wrote in your diary. You test the approach. The first one would work, but after 22 minutes, you figure out a pattern possible to form possible combinations. Trying to prove case. How to implement. Sure, 52 to 109. Did you spend an hour on this? Yeah. Okay.
Yeah, I spent. Yeah.
Different ideas. Nowhere. Is your problem able to get an idea of the fundamental to work? On second idea, if I was better, I generalized more like EPI solution, tried to derive no and no try to divide based on formula. That's okay. Did not try to make use of a simple way to validate an EPI. Something part of the code is quite complicated. Yes. So basically, when I run into something where like the code is very complicated, chances are I would say eight times out of 10, I'm doing something fucking wrong. The other two is like probably it's necessary. But usually, I won't know until I look back on the problem. So when I'm in the middle of it, I'm not going to second guess myself. But this is like only my solution when I look back at the problem. So let's see where I think one of them is like, oh yeah, the non-attacking queens part of it is that you try to bite off more than you can chew. And that led to a very messy imputation. Avoid one. I'll place a queen, possibilities. In the case number of queens are 1 is required. In case number of queens are the 1 required.
Yeah, the one required, like, I mean, for example, n equals to 4. So I'll try to define a base case for that. For example, if, like in a counter, I was trying to use like this, yeah.
Yeah, your description just isn't clear. I think that's the one thing. I think I'll look back on like what I showed you in the last coaching session. It should be as clear as that. Remember what I said about like a 5-year-old child? Like looking at this, if you have to qualify it to me, if some random person has to, if you have to explain that, chances are you're probably doing something wrong. Can you understand what this is saying?
Just in my head, yeah.
Exactly.
But probably other person is not gonna. Yeah. Because I had to explain for you.
Exactly.
And it was not clear. Yeah.
There you go. That's the problem. So simplify your explanation and make it clear and easy. Like I think like if I show you like you look at what I did, it's very easy and very self-explanatory. That's the goal of being able to write that. So let me write that down on a sheet. Okay. So it should be self-evident and easily understood by a 5-year-old child. And so that's part of it. Let's see, append the coordinates, possible comment, return it back. Yeah, it basically your explanations suck. I can't do anything with this because it's kind of, it just like your explanation kind of sucks for this, and I don't think you fully understood what you were doing here.
I think I put the wrong words, but like while you're creating this was making sense because I was trying to use the recursion in this call of place, you know, and
like the way I would describe the solution is literally place the queen on the board, eliminate all the possible squares that the next few queens can be placed, and then recurse into the next decrement the number of queens, and then recurse in, and then the base case would be if number of queens equals 0, then we know we've found a valid case. But you notice like how easy, like I could have written that in like 4 sentences, but you easily understood exactly what I was talking about. At least I hope I did.
Yes.
Yeah.
Oh yeah, I understand what you said.
Exactly. So being able to just say that in plain English and just like very simple, easy to understand is going to be that's exactly what we want to get to. So that's basically why I think you ran into issues here. So very basically simple language is basically what kind of blocked you. So yeah. So that's basically what I think you should work on. I would say try to look back at the problems that you didn't have this with, where you try to overcomplicate it, or you find that your resulting solution is overcomplicated, and then look back, see how you could have written that same answer simpler.
We'll do this.
Like, hold on, I want to show you something actually. Okay. Oh yeah, I can't really share it to you. I'll just paste it in your practice sheet. And so I think this is pretty much the way it should be. But let me show you something. So the 5 levels of intellect. I know this sounds like pretty fucking how to say, like fucking pompous and arrogant, but smart, intelligent, brilliant, genius, simple. You really want to hit simple. I don't care how complex and how crazy your solution is. I will value simple solutions over any of this other shit any day. We want to reach simple. That's basically the point I want you to focus on. Just it doesn't matter what kind of crazy solution that works if no one can understand it.
Yeah.
So I want you to keep this in mind. That's it.
Okay.
So, having done that, so is there anything else you want me to look at? I think I've given you a lot, and I think I've given you enough to work on. Your practice today, like I said, I want you to go back over the problems, look back on the stuff that you could have done better, simplify your explanations, and redo your evaluation of your mistakes, and figure out how to prevent them. And then once you do that, send that to me. I'll take a quick look, and then I'll give you a little bit more. But I would also like for you to try doing grokking after this. Okay?
They're grokking the entire like thing, right?
Just the recursion part. I want you to take everything that you've applied that you know here, and just retry the depth first search and the recursion area, and see if it makes a big difference.
Okay.
Okay. Let me write. Okay. So let me write down everything. And then so your homework. Redo the mistakes in the diary. Redo the problem explanation to the EL5. And then if you need more work, redo the recursion part of grokking. DFS part grokking with these tools. And then see if that makes a difference. I think you had a good start, but you kind of messed up on the follow up. But it's not that bad. So.
Okay.
Is there any other issues that you feel like that need to be addressed or need to be talked about?
No, I think those are the main ones.
Mm-hmm. Did you feel like we covered most of the confusing issues, or are you good?
No, yeah, I'm good. Okay. I was struggling with those things, and I see this repeating over, and was kind of lost. Where should I?
Makes sense. So if you see a common mistake, make a note of that, and then present that to me the next time we meet. Okay? Because we want to correct these as quickly as possible.
Okay.
Cool. I know we have 15 minutes left. If you have no other questions, I'll let you go early. I know it's late on your time. Get some rest, and then just keep practicing this stuff. And I'll see you on Saturday.
Okay. Okay, man. See you then.
All right. See you then.
Bye.
All right. Bye. All right. Cool. So with that, I guess there's one other. I think we'll go back to the IC thinking presentation. I think that's going to be pretty interesting. This is kind of a follow-up to... I'm just going to follow up the one I did on Saturday. So I'll give myself maybe 3-minute break. If anyone has any questions about what we just went over, feel free to ask. I'm gonna just get some drinks and I'll be right back. Okay. So Crow Sus asks, what book did you guys reference? EPI is Answers to Recursion? Yeah. So let me show the book. So the book I always recommend people use is Elements of Programming Interview. I've mentioned this before, but I think that they do a very good job at presenting the best solutions to these problems, showing you the step-by-step, and then always showing you the optimal answer as well. And I think it's really great. So this is the book I use. This is a book I have everyone else use, and I always have them compare their answer to what the book has, and then try and figure out how they can always get to there. That's basically what we're gonna do. That's basically what I make people do. So if you're preparing for your upcoming interviews, I highly recommend this book. I'm not even sponsored by them. I just legitimately think that they're the best book around, and I've never changed that since I started coaching people. So I guess we'll go into engineering thinking. I think this is kind of interesting. And I guess that with enough people, I guess that we'll get started. So if you remember last time, let's see, start slideshow. Engineering thinking. So just to kind of recap exactly what we talked about last time. Basically the goal at the L3 level, you're basically told what's wrong, you need to fix it, your bugs. L4, someone told you what the implementation contract is. And then at the L5 level, you are self-sufficient, you can lead a small team. And then the L6 level, you don't know, what you want, but you don't really know what the right answer is. So just to recap here, I put the recap over here. But the bottom line is, when you really do these projects, your goal is to really improve your skill set, and most importantly, to understand why things are the way they are. I think that this is kind of the big thing that people really miss out on at all these levels, because if you don't understand why bugs happen, you can't come up with the best or most solid implementation. If you can't come up with the most solid implementation, you can't scale your product. You can't scale your product, you won't know why it's the right answer. Especially when it's an unknown solution. So it's just the less you do at each of the previous levels, the more it affects you at the later levels. And this is where fundamentals come in, and it's the difference between having an 8-year career and a 15-year career. I think it's pretty massive, and I don't think people fully appreciate that until they're year 4 or 5 in. So that's my best advice for people, to really look at the fundamentals of what they're doing and why things are the way they are. Once you understand that, I think you'll be miles ahead of everyone else over time. So some of the mental models that I want to talk a little bit about, mental models that I use in order to try and evaluate projects. And I think these are pretty applicable at any level, although I would say they apply a lot more at the L5 plus level. So we really want, the way I think about a lot of these projects is how to achieve superior engineering value. And what exactly is superior engineering value? Part of it is doing a lot, being able to fit all the business use cases, or a lot of the business use cases, with little maintenance, being as efficient as possible with it, saving ourselves time down the road by having this code now, and having it do a lot. That's basically what engineering value is. And so one of the disciplines I draw from is from value investing. And the main question that in value investing is really what if you're wrong? You can think of a lot of the different ways in which you can come up with a project and why something might be the right solution. The question is, well, what if that solution isn't the case? What are the possible scenarios where you can blow yourself up? That's basically what you really need to think about when you're doing engineering. It's why is your solution wrong? Because it's one thing to say your solution fixes the initial issue, right? But then what happens if you just spawn a whole bunch of other bugs? That means that your solution is not correct, or at least it's a bad solution. And so the one way to think about this is you want to stack variables on your side. Knowing more about the world, or in this case the code base, is really going to help you make that argument and allow you to really think about these things. One of the other ways that I really get this exercise, if I read Howard Marks's Oak Tree Capital memos, a lot of the things that he talks about here in these memos are basically the exact same things you would consider when proposing a solution in engineering. Another way I think about these things is that it's like a game. It's if I'm playing against an opponent, I want to know what are the freebies that my opponents are making, are giving me, or what are the mistakes that they make, And in this case, the opponent is I would say code itself, or should I say the mismanagement of code in the future. What is the thing that I can do that will give me engineering value that doesn't require any maintenance or any kind of evaluation or effort later on? Those are quote unquote free. So one example of this is what free tools exist that have already been proven, tested, and that I can use and leverage, and I don't have to maintain or make that many modifications to. That's a freebie. That's a free lunch, and I want to be able to leverage as much of that as possible. I want to also predict what's likely if I want to go down that route, because in games like Dota, you really need to think about what your opponent's seeing, what is the most likely move, and what can you do to prepare for that. In this case, the opponent is really just the mismanagement of code, like I've mentioned. And so what are the different ways engineers can abuse my code or my solution? And I really want to be able to make sure that I can predict that and really understand, okay, well, if the engineers down the road are going to do this with my code, I want to be able to write some kind of implementation that will prevent that, but also is going to be worth my time to do. What can I do right now to prevent myself or prevent a shit ton of value from being lost in the future? So if you study pro players, in order to get better at games, you can study people who are better at coding than you in order to get better at writing code. So you might hear this thing from your coworkers where you need to be detail oriented, right? And for me, it just boils down to 4 questions. Why does the thing you're proposing work? Why is this the best solution? How does it scale in the future? And what the fuck will go wrong with it? If you really think about it, it's just really taking what you learn at the L3 level, L4 level, L5 level, and at the L6 level. Just asking those questions alone just basically will allow you to get all the details you need. And I think this is a pretty good framework for anyone. I think that anyone should be able to apply this to anything they're doing, whether it's bugs, programs, features, or even unknown solutions. And I think that it will prevent your boss from saying, why didn't you think about it? It's like, well, I asked these 4 questions. I answered it, and I got feedback from my coworkers about them. I think we did a reasonable job at trying to predict what will go right with this and what will go wrong with this. And this is something that I wish I kind of had in my toolbox. I kind of realized this a little bit too late in my career. And I've definitely had to pay my fair share of, penalty for not really doing that. For the longest time when I thought detail-oriented, I thought, oh, just throw more time at it, try different random shit, And it just kind of boils down to, what I tell people not to do in the coding interview, where they try spamming random problems. And of course, this gets better with time, where people try spamming random test cases to now become a little bit more structured with the test cases. But for me, the problem was not just that; it was the overall approach and questions that I was asking to the projects that I was doing. And I think this is a really good tool for people in the future. So I guess I'll run through this really quickly. But basically, think of this risk and reward is the engineering effort. The more risk you take on, the more unsure you are about the solution you provide, the more uncertain you have to be about the return. For instance, let's say I write some solution to a bug, but I have no idea how it impacts the rest of the code base, right? Well, this is the amount of return. It could be literally negative return if it's a lot of risk, which means that my ignorance is causing this risk. So this is the spread, and this is why engineering approximations are really, really bad, because in a lot of times, we're just kind of pretty ignorant about the world that we're in. And so the best thing we can do is just always ask ourselves, how can I get blown up? Why is this going to potentially waste people's effort down the road? And so being able to understand that I want to produce a lot of return for very little risk is the golden sweet spot. We want to be on this upper left-hand quadrant of this risk return quadrant. So we want to be here. And the better engineer you are, the more return you'll get for the less amount of risk, or at the very least, you'll be able to provide a significant amount of return for just a little bit of incremental risk. We want to play here, and that's the way you should always approach your project and your career. So let's roast me for a sec. I think that if we have enough people who want to participate in this, we want to be able to apply this to one of my projects. So job migration. The first real change from writing defined projects to the reason why I picked this is because it's the first real change I did from going from really well-defined products to not so well-defined products. Another one is the goals itself. Our goal is to migrate our entire code base from one language to another, effectively from Java 8 to Java 11. Let me move up my camera here. The third is and what we're given here is that the Java backend has done it before. And so the solution you might think is just, copy whatever Java has done, whatever the backend has done. And so we might just inject the libraries to make it compilable between both 8 and 11, and then just, run with that. But I'm going to tell you, this is at least what I first thought, but also it's kind of I would say kind of a trap. After all, we're, if we go back to the whole risk-reward, idea. It's like it's very little risk because we have something that is proven by the back end to work, and then we have a lot of reward because it means that if they have gone through the gauntlet and they've tested this solution, then we know that at the very least that we're going to get the same returns or very similar returns to them, right? At least that's the trap. I'm going to call it a trap because that's not always the case. Because if we think about the questions that we need to answer, once we actually think about it, we realized that, well, okay, how does Java code get compiled into Android code? What exactly goes on in this compilation progress? And how does Java and how does like the change from Java 8 to 11 actually impact all this? And so once we actually started taking a look at the surface area, then we actually started realizing there's a whole lot more to what we're doing. Making sure that we have good test coverage before we migrate to Java 11 does prevent us from breaking things. Yes, having that test is there. And that does, but it doesn't actually help us in making sure that we have complete coverage over the areas. After all, most of the tests that we've written only apply to like product, right? And they only apply at compile time, but they have no bearing on runtime. Because keep in mind, a lot of the things that you are going to be dealing with at Java is, runtime. Like, let me give you an example. Like, for instance, missing libraries. That might be available at compile time, but then they might be promised during the compilation process saying, hey, there's this thing called provide dependencies. And what that provides us, it says, hey, yeah, as long as we provide this contract definition, then at runtime, then it will be available. But then sometimes without those libraries in Java 8 got hidden in 11. And so that would actually provide a failure at runtime. And we wouldn't know about this until much later on. And so what this means, and the reason why, and this might seem a little bit complicated, but what this boils down to is being able to understand in what way Java 8 or Java in general actually affect our entire app. And not just the app, the building of the app, which means that we need to understand how the app is even compiled to begin with. We need to understand how Java interoperates with Kotlin. Is there things in Java 11 that Kotlin can't understand? That's going to be also a issue. The other thing is that once we migrate our code base to Java 11, and we migrate effectively our entire developer environment there. And so therefore, all this Java dependent tooling will actually break. And what you find is that a lot of Android tooling is Java based, right? So Jetifier being able to, it's like jetification, monitoring and debugging the app as well. Like all these are Java tooling, and which means that once we migrate to Java 11, this tooling will break unless we know for sure that Android could actually handle all this. Jared asked, could we record user traffic and reply in the test? Well, that's the thing. We're not actually dealing with user traffic. We're actually dealing with compile time. We're actually dealing with the end user who, in our case, right now, is actually the developers themselves, not like some random person who's using the app, right? It's actually developers who compile the app. That's our actual customers, and we want to make sure that these things actually don't hurt them. Another thing to consider is that third-party dependencies. Well, it turns out third-party dependencies are going to come to us as a jar, right? So, in other words, even though the contract might be complete, they might be calling some deprecated Java 8 libraries. And that will break at runtime. They'll when you run these, it'll just say, hey, this library doesn't exist. You'll face a runtime failure. And so the surface area risk that you expose is that, well, the third-party libraries that we're using might not support new Java. We need to import them. We need to upgrade them. And with that, we need to make sure that we support all these new APIs. So as an example, if I use a third-party library that doesn't support Java 11, and then they decide to bump it up two or three versions later, then during those 2-3 versions that I've missed out on, I need to catch up. Did they make any changes to the contract I'm using? Do I need a refactor for that? And turns out this was an actual issue for Kotlin Poet. So you begin to see here all the standard things that you might think about, do we have the unit test should cover it. The runtime and acceptance test should cover it. The test that the India testers should, and the runtime, we should be able to cover it, right? Well, it turns out there's a whole lot more to it than we initially thought, and I was guilty of this. And the reason why I highlight it is because these are the things I missed. So if we go back to the questions that we need, if I go back to the whole detail-oriented thing, right? Why does this work? Why is the best option? How does this scale in the future, and what will go wrong? The question that I missed was what will go wrong. And the reason why I missed this was because I needed to actually answer, what does the end-to-end of this whole process, this whole compilation process look like? And how does Java actually affect each one of these areas? So you can see here, even on the surface, it looked okay to copy whatever the Java backend did. But you can see here, like, because of the change in ecosystem, there were a lot of other questions that I missed. And because of that, that actually threw a huge wrench in the project that I proposed. I handled all these because, fundamentally, we can think of Java as just one big library that everything relies on, including the compiler, because the Java compiler is built in Java, right? But then you need to actually understand every single little detail, and then once you understand every little detail, the end-to-end story, then you begin to understand what other parts of the experience that Java touches. So, where am I going with this? So, why was this work? Why did this not work? How did this allow us to scale in the future? Why was this solution actually okay? So, I kind of addressed what will go wrong. Our customers are the developers, right? And the worst possible scenario that we can ever run into is that, well, they will break, right? Well, the thing is that just simply upgrading the library step by step was actually the right thing, because that means that we could be compiled in both 8 and 11. We restore whatever libraries weren't available in 11. And then once we got a step by step, then we know that we can use the backend or whatever is in our CI/CD system, upgrade that to 11. And then we can just slowly prove over time that as long as these CI/CD pipelines don't fail, we know that it will work with 11. And then eventually we can ban a compilation against 8. That's fine. And this is actually the safest rollout, I would argue, because now while you're trying to fix all the stuff related to Java 11, the Java 8 experience is not interrupted, and the developers don't notice until you're ready to flip that switch. And once you're ready to flip that switch, you manage the developer environment for them, saying, hey, we will upgrade all your machines to 11, and then boom, presto presto, they're on 11, they don't care. They're going to still write code. They're going to still write code all the way. And what you get is the benefit of upgrading to Java 11 and whatever all that entails. And so this allows us to actually roll back and take out stuff as we need. So for instance, let's say that there's some runtime issue. Well, okay, now we will ban compilation against 11, go back to 8, we can reverse back, and we can back out of whatever the hell we did and fix that issue before we go back in again. So there's a lot of safety mechanisms built into this plan of scaling and of rolling it out. So this is like actually the plan that we actually used. And the fortunate part is that because of that, we were actually able to buy ourselves time and not break developers. Now imagine if we made like a hard commit to 11, we made a hard refactor, we refactored everything to use like the new APIs, the new everything, right? How do we roll that back? We can't. We're fucked, right? So for instance, let's say Java 8 has some function calls to some locales. And then those like some calculations with pi or something like that. And then Java 11 decided to, hey, we're going to take those away from you because you shouldn't have access to that. And let's say that we decide to do a very hard commitment and say, hey, let's refactor everything to use the new Java 11 API. That's a hard commitment. And if we fuck up, we can't easily roll that back because we're dealing with a 3-4 million line code base that changes every single day. The moment I roll forward like that, and the moment I make that hard commit, it's going to be very difficult to revert that because there's probably thousands of places that use that banned API or rely on it. And then once people overwrite that change, it gets exponentially harder to actually revert it. So doing like a git revert on such a large change is it's like a death scenario for us. So just simply restoring the libraries that were hidden in Java 11 or removed straight up was actually the best case for us. So I think like really thinking about that is actually quite good. So Steven says, I thought that each version of the JDK kept an old copy of the GIRE, so that there was always backward binary compatibility. So let me show you an example here. Let's take a function in the wild. Let me pull this up. This one is a very good example because I actually screwed this up. Okay, so here, let's use an example here. This one wasn't like a straight up ban or removal of functions. So let's say, how do I use unsupported locales in 11 and numbers string format? So for instance, the locale, because of the way that Java 11 actually changed the way they were like evaluating locales, the output of certain strings would be different. So like for instance, in this example, Java 8 well, just put a locale of 120, right? But then in that exact same code in Java 11, we'll output something completely different. So the way I think I handled this was, yeah. So the way I handled this, it's very simple, right? It's just adding some compiler argument. And then just say, hey, evaluate the locale based on this. But the underlying is going to still like fuck me up. Imagine if that underlying, instead of like switching locales, it was just straight up removed. Well then, I would run into some compile time or runtime issue. And this would actually completely screw me over. The second thing you need to keep in mind is that because of the way Android works, and I'm going on a little bit on a tangent, but I think this is actually super interesting, is that Android, when you compile Java code, it will actually spit out Java 8 code. You can't do like source target 11 for it. The reason why is because you have so many other Android devices, right, that are all over the world that are basically built against Java 7 and Java 8. And so the output code that you need to write out needs to be Java 8 friendly. And so when you compile Java 11 code, it needs to spit out Java 8 code. And so you might have some like language features in Java 11 that cannot be represented in Java 8. So for instance, like there's some syntactic sugar, like being able to have like those weird implicit types. Now the way this would be done actually is through a process called desugaring, where Android will actually take that Java 11 code and then remake that using Java 8 friendly stuff. And then it'll produce the bytecode for that, and then it'll actually create it for you. And that kind of goes into the whole compilation step. And so really one of the things you really need to look out for is whether or not a lot of this Java 11 stuff that is language features will actually work when you decide to make the source and when you decide to make the target, the output of that 8. Will the desugaring actually take care of that? That's what you need to really think about here. And so I know I'm kind of going on a tangent, but the point here is that there's a lot of surface area that you really need to think about that you never really actually think about at the very beginning. And you only really get to this point when you actually think about, like, when you actually consider all the different steps that are affected by Java. So now knowing that we fucked up with this highlighting, how can we improve our thinking? Well, if we approach this with a more risk-oriented framework, then this actually becomes a little bit easier, because now we say, oh yeah, these are all the different places that Java gets used. So like the tooling, the Kotlin interop, all this different things. So if I evaluate from that, like what are the different ways that I can get fucked up here, then the questions and answers actually become very, very easy. So for instance, looking at that locale example, like, well, I know that some of the text that we're generating on the app is based on the Java locale that is coming from the Java 11 or Java 8 standard library. And so that's one place I can die. It's that, oh yeah, well, all these tests that implicitly rely on Java, I need to make sure that those tests are in place. And fortunately, we did have those tests. So now I have to figure out, okay, well, how do I restore the Java 8 the functionality? And another way to look at these projects is to model the projects after similar other projects that we've done. Like I said, the one way I thought about this project was that Java is essentially one big library that everyone relies on. So why don't I just model my approach to this as if I was refactoring or moving one big, heavily dependent on third-party library. So we modeled this to the Java upgrade. Java 11 is just a glorified big library that everyone depends on. I've already said this. That also affects the compiler. But once we actually see this, we can actually focus in on all these different things. So the big library. Well, what does a big library migration look at? Everyone. Who is everyone in this situation? Like in this case, it would be our developers. And then it affects the compiler. Well, then this means that we need to understand the compiler. And if we just make this mission statement, if we make this model beforehand, then we actually understand what are the questions and topics that we need to deep dive into. Well, especially in this compiler area, which is not something that everyone really thinks about. So this goes into the plugins we might put into the Java compiler, the desugaring, the bytecode generation. How does Java even get compiled into Android? And is this going to be affected by our migration? So this is like, and everyone, again, developer tools. Our developer is going to be affected by the Java 11, not just like I mentioned before, where people might compile, crash, and do all the crazy shit, but then and have their developer experience and their shipment of code completely fucked. But then also the tooling that they use, because again, if I upgrade Java, then I'm affecting the development environment that they're in, and what else in their environment relies on Java. Once we actually invert that and really think about like what this surface area actually affects, it becomes very easy for us to actually maybe get a little bit maybe actually ask ourselves these questions and not get blown up here. And this is something I honestly should have done. All I've thought about, only focused on, was the big library migration, not affecting developer experience and the compiler. But then in the end, if I really thought about not just that, but also thought about the developer experience of like what tools and surface area that got touched here, I think I would have done a better job. And I'm sharing this with you because I think that just simply asking myself the surface area and asking, like, modeling all this and understanding what is affected actually will do a lot of good when you're doing even a big project or a small project. I think getting into this habit is actually very, very crucial. And so the lessons here, I think, is that being able to model and tell your story of like the project that you're doing, and being able to convey that and plan around that is a very good mental model. Being able to use these different mental models of evaluating projects is really, really good when you want to be able to deliver and evaluate your risks. Because keep in mind, the moment you start thinking of this, not just from how do I complete this, but how do I prevent myself from blowing up and failing on this project, you actually start like thinking about a whole lot more questions. Of course, this kind of like means that you are going to be a little bit more paranoid, but at the same time, it prevents you from running into random shit that will prevent you from delivering. And you know, Andrew, I think it's a very healthy way of thinking about these things, even though it's like a completely against human nature. Humans don't really like thinking about like things that can go wrong. We always like thinking about things that can go right and things that will go right because it makes us feel good, right? But thinking about things that can go wrong and things that can blow us up is also part of it, because that's part of project planning, and risk management is your friend. You can't just like say, oh, I'll just throw more time at the effort, you know, like, oh, if this doesn't land on time, I'll just go ahead and put in like a 16-hour day, 20-hour day. But I would argue that there's only 24 hours in a day, and there's only so much that you can do. And having better planning and thinking about the risks that you can run into is going to make your life a whole lot easier and save you all that grief. There's only so many hours in a day, and there's only so much time other people are willing to put in. So being able to clone previous successful projects approaches is also pretty good. But most importantly, the free lunches are good. You know, they're very rare in projects, but being able to find the risk-free value plays and the risk-free solutions is almost always the right solution. And I think it's very well welcomed, because at the end of the day, it's just saying, hey, these guys did this. It's free. Let's fucking use it. So I kind of want to wrap this talk up with a quote from Mark Twain. It's not what you don't know that gets you in trouble. It's what you know for sure that just ain't so. And I know I spent a lot of time talking about like the things that I don't know, but I want to kind of caution you on the things that, well, what if you have mistaken knowledge? And of course, like the whole research process really helps you to solidify and make sure that what you thought was previously the case isn't actually the case, and so on and so forth. But starting projects on faulty premises is one of the greatest ways to get killed. You know, you might propose like, hey, we think that this project can actually be done. But then without testing it, you know, it's a great way to just waste your time. This is why I, like in my video on submitting projects successfully, I advocate for writing some kind of test project or some kind of, you know, like a sample that proves that this project can work. And being able to go through that exercise really helps solidify and iron out what information you don't know and correct what misinformation you might have. So I think that's it for me. I know I talked a lot, and I think this was relatively a little bit. This is like kind of like the last 20 minutes of the talk I wanted to do. And if you want to watch like the first few talks, the first part of this, it's in last week's stream, and I would recommend you go watch it. But at the end of the day, I think that no matter where you are in your career, I think a lot of the topics here, you can rewatch this talk and just get a whole lot of value out of it. But the point here I want you to really think about is to not approach this from how do I get things done, but I want you to approach this from how can I prevent myself from getting blown up and not delivering? Or at the very least, how can I make sure that whatever I'm writing actually works and will continue to work in the face of adversity in the future? So I think just simply approaching all your projects and everything from that angle is, I think, a very powerful tool. And I honestly wish I kind of like figured that out. But, you know, I'm learning as much as you guys are about this. And for me, this talk was just as much about conveying knowledge as much as it's solidifying my own knowledge and instincts. So I'm guessing that's it. If you guys have any questions, feel free to ask. I'll be hanging around for the last few minutes to answer any of them. Otherwise, yeah, go nuts, man. How can I make sure my life is doable later in the future, I guess? Yeah, how do I make sure that the work I did stays intact and continues to provide value in the future. That's like the way I want to see this. I want to make sure that the amount of effort that I'm putting in will generate incredibly high returns. And that can mean like spending an extra 5-10 minutes thinking about what else can go wrong. And if I can think about that and incorporate that into my solution, that just increases the amount of return I have just for like a little bit more effort. It's being able to create more and more returns with the amount of effort that I'm putting in. And like that also means preventing someone else from completely fucking up my code, or at least misusing it. So, and that question applies no matter what level you're at. Guess I'll put on some Dota. Man, I have not played Dota in like freaking weeks, man. Alright. Is there any other, Yeah, I'm gonna watch and wait for other questions. Oh, shit. 11-1. Damn. Alright. The Medusa's actually pretty far at. The Medusa's head, but the Ember Spirit's... Yeah, the Ember Spirit's feeling a little poor right now. Okay, this fucking guy, this Polaris guy is like 12k, I think. Or 11k. I don't know. He's like really one of the highest rated players in Southeast Asia. He's really good. So it kind of hurts and sucks to see him like get kind of owned like this. I think late game, late game, as long as the Medusa stays ahead, they're gonna win. But the Razor actually gonna be the biggest thing here, because as long as the Razor gets a static link on Medusa, that's his only job right now. Okay, I guess since no one else is asking any other questions, I guess I'll stop the stream for today. Thank you all for joining me. We will have another stream on Saturday with my client. We'll be going to the next session. Hopefully he learned a lot from this replay analysis, and hopefully he fixes his issues. Hopefully you guys learned something as well. We'll do the stream on Saturday at 10 a.m. With that, have a good night. Thank you all for joining me, and I'll see you then.